Hi class, Mr. Falstrom here, and in this video we are going to practice multiplying mixed numbers using area models. And the learning goal is exactly the same as the title. We are going to multiply mixed numbers using an area model. So let's just jump in. This is going to be a longer video. All right, this is our first area model. So my first question is, what is the value of the red dot? And just to give you a little bit of extra help, let me kind of help number this number line for you. So by looking at those numbers, can you tell me the value of the red dot? And you can see that the blue dots show where the hole is. And going across the bottom of the hole, it's divided into 4 equal parts that way. So we have 1/4, 2/4, 3/4, 4/4, and the red dot would be 5/4. And if you want to rename that to a mixed number, you could say 5/4. You could also say it's the same as 1 whole plus 1/4, 1 and 1/4. So now let's look vertically going up and down, and what is the value of the green dot? And there's some help for you. And if you look going up and down, the whole going that way, it's divided into thirds. So what is the value of the green dot? So if we're counting from 1/3, 2/3, 3/3, 4/3, 5/3, the green dot would be 6/3. And another name for that would be 2 wholes. All right. So now that we've figured out the green dot and the red dot, what is the multiplication problem that we are going to be solving? Take a guess. And if you want to, you can use any combination of names, but we're basically multiplying the green dot by the red dot. Both of those are fractions that are bigger than 1 whole. So if we want to look at it as mixed numbers, we could say it's 1 and 1/4 times 2 wholes. If we want to kind of rename those, we can also say it's the same as 5/4 times 6/3. And so that's what we're going to figure out on this example. I'm going to kind of reset my slide to give us more room. So there's the problem we're going to be doing. Let's look at 1 whole. How many pieces make up 1 whole in the model? So I mean, just count the yellow rectangles. How many pieces are there? And if you count them all up, you should get 12 pieces. So if there's 12 pieces that make up a whole, what is the name for, or the size of 1 piece? What would we call that 1 piece if it's 1 out of the 12 pieces? We would say that 1 piece is equal or equivalent to 1/12. So one way we could figure out the answer to this problem is, or figure out the answer to the model, is we can just count all of the shaded pieces, all of the gray rectangles. If we just count up how many there are, how many 12ths are there, that would be 1 answer. So go ahead and just, answer that for me. How many total 12 pieces are shaded in the entire model? So every gray square or rectangle. And if you count them all up, you should see that there are a total of 30 the whole thing, if we count them all up, you should see at a total of 30 12 pieces. So that's one way if you're given a model like this and you were being asked to solve it, you could figure it out like this. You could just figure out, okay, well, what are the size of the pieces? And then just count up how many shaded pieces there are. So that's one way. Just figure out how many pieces make up a whole, figure out the size of one of the pieces, and then count them all up. That's one way to do it. Let's look at some other ways. So we already know that the one answer to this is 30/12. Let's kind of look at our equation we had. Okay, so another way of doing this is we're trying to figure out the area of 5/4 by 6/3. So if we multiply 5/4 by 6/3, what do you get? You also get 30/12. Mind blown. That's another way to do it. So if you can just figure out the values of the dots, the green dot and the red dot, figure out what fractions those are and just multiply them, boom, you're done. But let's not stop there. There's actually a bunch of other possible answers to this that would also be correct. And I want to kind of talk about those. So we already kind of went over 5/4 by 6/3. It's 30/12. And if you chose to rename it, you could rename 30/12 into 2 wholes and 6/12, which is also, you can simplify 2 and 6/12. 6/12 is equivalent to a half. So you could say that 2.5 is also correct. So let's look at some other possibilities here. You could do 5/4, and you could take 6/3 and rename that to 2 wholes. So if you did 5/4 by 2 wholes, you would get 10/4, which is also, so 10/4 is also a correct answer because that is also equivalent to 30/12. It's also equivalent to 2.5. And then yet another way could be if we just chose to do the original problem, the 1 1/4 times 2. If we did it that way, well, 1 1/4 times 2 just means 2 groups of 1 1/4. So if you just added 1 1/4 plus 1 1/4, you would get 2 2/4, which is correct because it's also equivalent to 2.5. So there are so many different combinations here for what you can do. You could count up, you can figure out the size of a piece in the whole and just count up all the shaded pieces. You can find the value of the red and green dot, and it doesn't matter how it's named. You could keep it as a mixed number, or you could rename it as a fraction greater than 1, and any combination of you multiplying those will get you to a correct answer. And it's up to you at that point if you want to simplify that answer or keep it as it is. All of these things are correct. 30/12 is correct. 10/4 is correct. 2.5 is correct. 2 6/12 is correct. 2 2/4 is correct. All of those are all equivalent. They all have the same value. So moving on. I just want to say, wow, look at all the different answers. And that just kind of makes me want to reflect for a second and just say that math is pretty cool. I like problems like this where you have so many different possibilities and different ways to solve it. I think that's cool. So let me ask you this. We just went over a bunch of strategies, and I want to ask you, which one do you think is more efficient? This is a personal question. It's up to you. Tell me what you think. But the very, very first way I showed you, you got to draw a model. You got to set everything up. You have to be precise. You got to label everything. It has to be neat. Can't make any mistakes. And then once you got it all set up, you got to figure out the size of one shaded piece, and then you got to count them all up. So that's like the very first one we went over. And then the other strategy was just rename the mixed numbers into fractions and multiply them. And we just did 5/4 times 6/3 and got 30/12. Which one do you think was more efficient? Counting up all the squares, or just multiplying the fractions? So here's the thing. There's a big difference between drawing a model yourself and being given a model that you have to figure out. I am not you're not going to be asked to draw a model on a test. But on a test, somebody might already the test might give you a model that's already drawn, and you're going to have to figure out the model. There's a big difference. But if you don't practice drawing some of your models and trying to understand how they work, then you're going to have problems. You're going to have difficulties figuring out a model that's given to you. So before we try and figure them out, we're gonna do some practice later on in class where I want you to practice drawing your own model. And I realize that that's difficult. And right now, some of you watching this video, you might be saying something like, or thinking something like, why can't I just multiply and do the easiest strategy? I am not saying that you can't do that. If you get if you get a problem that just looks like that already has the numbers there for you, go ahead. You can rename them and multiply, or you can draw the model. It's up to you. I don't really have a preference what you do as long as you get it right. So, I mean, if you get a problem where it's just given to you like that, heck yeah, multiply it. But if you're given a model, let's say you have a question on a test that looks like this. Well, guess what? You've got to figure out what numbers are actually getting multiplied in the model. And if you don't practice drawing models and figuring out how the models work, it doesn't matter how good you are at multiplying fractions. You're not going to be able to do this problem because you don't know what fractions are being multiplied. So drawing the model, even though you might think it's useless, let me kind of ask you this question. It's not going to sound like it has anything to do with math, but why do people do arm curls? Why do people do those? And they do them to get stronger, right? They're exercising their arms. They're making their muscles stronger. But how often do you actually use arm curls in your everyday life? Do you walk around curling your arms all day? Probably not. Probably not that often. But does that mean the exercise is worthless and that you should never do them? Of course not. Even though you don't do arm curls in real life every day, it's still important to do exercises to make yourself stronger. And that's exactly what we're doing here with math. Learning how the model works and practicing with it, you're working out your brain. It's valuable, even if it's not something you're going to use in real life a lot. I am not saying you're going to need to know how to draw area models the rest of your life. But if you practice with them and understand how they work, you're training your brain how to learn new things. You're learning how to absorb new information. You're making your brain smarter. Even if it doesn't make sense, just the fact that you're struggling with the problem, you're working with it, that's helping you. And then, of course, if something doesn't make sense, then you ask for help. Just like in sports, if you don't understand something, your coaches correct you. That's kind of what teachers do too. So I know some of you are like, can we skip the area model? Do we really need to do this? Well, if you're going to get area model questions on a test, you better know how it works. So let's try and practice a little bit with one more problem. So I've already got this kind of labeled for you. Okay. I want to know what is the value of the red dot. And the red dot, if we have 1/2, 2/2, the red dot would be 3/2. You could also say 1.5 because those are the same thing. Okay. So if you were able to figure that out, that's good. You're understanding how the model works. Okay. Let's now figure out the value of the green dot. And you can see I've kind of labeled most of the points for you to kind of help you. And The value of the green dot, if you aren't really sure where I'm getting halves from, maybe if I kind of draw here real quick, that can kind of clear stuff up. So if you kind of look at these blue dots right here, that's one hole. From here to here is one hole. From this blue dot to this blue dot is another hole, and all the way up to the green dot is another hole. So if you kind of look this way, if I'm looking at this side, if this is a hole going this way, it's been split into two equal parts, right? Here's one jump, one half. There's two halves. This has been split into two parts. This has been split into two parts, right? So if I just do my jumps, that's 0 halves, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So again, if you look at this whole thing right here, this is your hole. The blue dots, from blue dot to blue dot is a hole. So going this way, it's been split into two parts. So if you weren't seeing it, hopefully now that makes more sense. Sorry with the erasing. You know what I should have done is I should have paused this, erased, and then hit record again. But it's too late. Okay. So the green dot. The green dot is equal to 6 halves or 3 holes. So what is 6 halves times 3 halves? That will give us our answer. And 6 halves times 3 halves gives us a total of 18 fourths. And if we come back here and we look at one hole, if you just look at one hole, you can see this has been split into 1, 2, 3, 4 equal parts, which means that each piece is equal to a fourth. I remembered to pause and erase this time. So there's a fourth. That's a fourth. Here's a fourth. And here's a fourth. There's 4 pieces in the hole. 1, 2, 3, 4. 4 fourths is equal to 1 hole. Every single square in this model is the same size. Every gray square. So those are fourths. These are fourths. And I could keep drawing them all. But if you realize that every one is a fourth, you can just count them up. So, I mean, if I just kind of count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus the other 4 there, that gives us 18 fourths. So if you're given the model and it's already there and you don't have to waste time drawing it, it'd be, figuring out the size of a piece and counting it is not that bad of a strategy. It's not that inefficient. If you can figure out the names of these fractions and just multiply them, that's also quick. So you really, there's a lot of different approaches you can take here. Hopefully one of these makes sense to you and it works for you. I need to erase, so give me a second. All right, I'm back. And I'm done erasing just to say thanks for participating. That's kind of the end of the video. I'm going to be working with you in class to practice drawing some more models and working with some more of these. So I hope this video made sense to you. Thanks for watching the whole thing till the end. And I'll see you again on the next video. Good job.